So hi everyone, today we are going to solve LeetCode 104. It's called maximum depth of binary tree. It's an easy question. And the question goes, given a binary tree, find its maximum depth. The maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So a leaf node is a node with no children. Okay, these are leaf nodes. So in this example, apparently the length of the longest path from root to a leaf is 3. It's either 327 or 32015, not 39 because its length is like 2. So apparently we count the number of nodes from root to the leaf, farthest leaf. So how can we solve this problem is we can use DFS in this example. So we can run a DFS from this point, the root, and we can just count how many nodes do we have from the farthest node. But doing that from top to down would be a bit harder. So what we're going to do is we're just going to have this recursive structure where every node, when used in the BFS, will return the number of nodes from that node to the farthest leaf node that node has a connection with. So the idea is like this. So run DFS from node. It will return the longest depth of that node. So when we have a node and it has left subtree and right subtree, we will just take the maximum of those longest depths because both paths can be reachable from the parent node. And we will just add 1 to the longest path to the DFS here. So let's just code it and we will see that it will work and we will get the understanding. So let's start with just handling this thing here. If root doesn't exist, just return 0. So otherwise what we are going to do is we are just going to use a DFS and we are just going to send a tree node. Let's call that also root. So here what we are going to do is if that root doesn't have a left child and it doesn't have a right child, which means this is a leaf node, let's write that here, then what we are going to do is we are just going to return 1 because the length of a longest path from a leaf node is 1. It's just itself, right? So we handled the base case. So what we are going to do is we are just going to check independently if this root node have a left children. If we have left children, what we are going to do is let's keep 2 variables. Let's call them left and right. Okay, and left is 0 and right is 0 at first. Okay, so left is going to be updated here and the value is going to be DFS root left. Okay, and also we are just going to check if we have a right child, and the update of this variable will be done here with a DFS to the right hand side. Okay, this will return apparently the longest path length of the left node, and this will return the longest path of the right node, and what we are going to return is 1 plus because we are a node ourselves, the root one, and the maximum of left and right. Okay, so this is going to return the answer for every node that is sent to this function. So what we are going to send is basically the root node. So we want the answer for the root node. Let's see if this works. So this works on this example, but does it work for all examples? Let's see. Yeah, it works and it's pretty fast. So let's talk about time complexity here. The time complexity is We are just running a DFS which has time complexity of O E plus E normally for a graph, but just because this is a tree, we do not have like on the order of v squared edges. We just have v minus 1 edges actually, v being the number of vertices. So our complexity for a tree is v plus v minus 1, which is equal to O of v. Or if you prefer calling this n, O n. So thank you very much for watching.